Okay, so what we have learned so far was something called as triangle law of vector addition. तो अभी हमने सीखा वो था ट्रायंगल लॉ ऑफ वेक्टर एडिशन, बिकॉज उसमें एक ट्रायंगल बनता है. नाउ वी विल मॉडिफाई इट and we will make a parallelogram law of, we will modify it and we will make it a parallelogram law of vector addition. Okay, so let us see how to do the parallelogram law of vector addition. So we have two vectors. Now here we will find out the magnitude as well as the direction. So look at it carefully. We have two vectors. One vector is vector p. Let us say that this is vector p is here. Okay. Other vector is this is vector p. Okay. Other vector is vector q. Okay, I want to add them. So how do I add them? So let us pay attention. We will use a parallelogram law of vector addition. This is a more detailed law than triangle law. So let us first translate p as it is. So I'll draw a diagram which is very little bigger and clear. So vector p I have drawn. Then on the top of it, now here what I'm doing, I am taking both the tails together, okay, and I am drawing my vector q here. Okay, both the tails you can see they are joined together. Now to p I draw a dotted line which is parallel to vector p. Okay, and I draw a dotted line which is parallel to vector q from the head of p. So you can now see that this becomes a parallelogram because upper line is parallel to lower line. And if I can give some name, let us, this is O, this is A, this is B, and this point is C. Okay, so draw P and Q as two sides of parallelogram OACB. Okay, let us say that the angle between the two is theta. This angle is theta. Now you can now see that if this length is q, this length is also q. Why it will be q? Because it is opposite side of the parallelogram. Okay, so length AC is equal to q. Now what is the resultant? What is the sum of the two vectors or resultant of the two vectors? The resultant of the two vectors can be drawn from this point to C. Diagonal. This is the resultant vector R. You can now see that OAC is again the triangle law. OA is like P, AC is like Q, and sum of the two is R. So vector R is nothing but sum of P plus Q. Correct? Our aim is to find out magnitude of R. What is the magnitude of R? ये क्या होगा, हमको ये पता करना है. So to find it out, what we do is we extend OA. Extend OA. So we extend OA further. Okay? And drop a perpendicular from C. Let us call this point as M. So you drop a perpendicular CM perpendicular to OA. Okay, you drop a perpendicular. These are construction. Now you have got two triangles. Can you see? One large triangle OCM and one small triangle ACM. Correct? Both are right angle triangles. Triangle OCM is right angled. So can I write Pythagoras theorem? Right? What is Pythagoras theorem? How do I write in triangle OCM? Can you tell me?
OC square is equal to OM square plus 9C square.
Right. So you write Pythagoras theorem. OC square is equal to OM square plus CM square. Correct? But you can now see that OM is made up of two parts, OA and AM. So can I write OM as OA plus AM the whole square? Am I right? See, this is OM. OM is from here to here. It is made up of two parts, OA and AM. So OM can be written as OA plus AM. And OM square can be written as OA plus AM the whole square. Right? So what do we write? We open the bracket. How do we open the bracket? OA square plus AM square plus 2 times OA times AM plus CM square. Where is the confusion? See the diagram? You want OM. OM is made up of two sections, OA and AM. So this OM square can be written as OA plus AM the whole square, because it is made up of two sections, and therefore you can expand A plus B the whole square. So A square plus B square plus 2OA plus 2A OA AB plus CM square. Okay? Very correct. Now I can go to the smaller triangle. This is, let us say this is equation 1. Now you go to the smaller triangle, CAM. And can you again write triangle CAM is also right angled? Am I right? So can we write Pythagoras theorem for that also? How do we write?
AC square plus AC square is equal to CM square plus AM square.
Okay. AC square is equal to CM square plus AM square. AC square is equal to CM square plus AM square. Correct? Now, if you look at it carefully, you get both of these two terms, Cm square plus Am square, in equation 1. Cm square and Am square. What does it mean? These two can be replaced by AC square. Am I right? If you look at equation 1, you get Am square plus Cm square, which is same as the right hand side of this equation. I may call this as equation 2. सिट स्ट्रेट नंबर दिखेगा ही नहीं तो आंसर कैसा देगा?
समझ में नहीं आ रहा।
तो लेटेगा तो दिखेगा ही नहीं, दिखेगा नहीं तो कैसे समझेगा? समझने के लिए जो 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 इक्विपमेंट वो लगाओगे नहीं तो नहीं समझेगा, दिमाग, आँख। I'm saying equation AC square is CM square plus AM square. While in equation 1, if you see, you already get these two. CM square भी है, AM square भी है. These two can be replaced by AC square. बराबर? So using 2 in 1. So what 1 will improve to OC square is equal to OA square plus, now these two can be replaced by AC square plus 2 OA into AM. Correct? Now we will look at what is OA and what is AC. If you look at it carefully, come to the diagram. OA. OA is nothing but magnitude of P. Length of OA is nothing but magnitude of P. So I can write OA is nothing but mod of vector P, which is simply, I can write it as P. Okay? Length OA. This we are talking about length OA, not the direction. Lambai. Similarly, what is AC? Let us check the diagram. A is here, C is here. So length of AC is nothing but Q, which is opposite sides vector. Okay? So we can always write AC is nothing but mod of Q, which is nothing but length of Q. What is OC? Look at the diagram. O is here, C is here. So OC is vector R, represented by vector R. So OC is nothing but magnitude of vector R, which is simply R. Okay? So now the equation simplifies. OC can be written as R. So OC square can be written as R square. ठीक है? OA is nothing but P. So OA square is nothing but P square. AC is Q. So this can be written as Q square. 2 OA. OA is again P. And AM. We haven't yet find out what is AM. So let us try to now find out AM. Okay? What is AM? AM is this small little triangle. It comes from this little triangle. how would it come from this little triangle? Because now this is something which is tricky. So first question is, what is this angle? How much would be this angle? So you will find that these two lines OB and AC, they are parallel, and OA is a transversal. Therefore this angle theta has to be equal to this angle theta. Correct? What do we call these angles as? Corresponding? No. उसका नाम है ना? Alternate. These are corresponding angles. So they are same. So now focus on this. I want to find out AM. How do I find AM? So AM is, if you look at angle theta, AM is adjacent side of theta. Correct? AM is adjacent side. AM is adjacent side, while this is hypotenuse. So I can deploy a trigonometric ratio. What is a trigonometric ratio that I can deploy?
Cos theta.
Cos theta. So cos theta will be what? Cos theta will be adjacent upon hypo. Now what is adjacent in this case?
AM upon
AM. What is hypo in this case?
AC.
AC. So what is AM then? AC times
Cos
theta. But what is AC? AC is Q. So what is AM then? Q times cos theta. You understand this? So I can now use AM as Q times cos theta. So my R square is P square plus Q square plus 2P, and AM is Q times cos theta. So what is the resultant vector? R. It is a square root of P square plus Q square plus 2PQ cos theta. 2PQ cos. This is called parallelogram law of vector addition. Now this gives you the magnitude of the resultant vector. Magnitude of resultant vector. In triangle law you will get a rough idea that how resultant may look like, what direction it will point. But if you want actual values, what is the length of sum, you will not get from triangle law. So triangle law is a shortcut. If you want a very quick idea, just an idea about that where the resultant point to, use triangle law. But if you want to find out the actual value of the actual sum of the resultant, then you use the parallelogram law. Okay. Now this is the magnitude. What about the direction of the resultant? How do we get the direction of the resultant? So to get the direction of the resultant, we deploy more to it. So we always measure the direction with respect to one of the original vectors. हम डायरेक्शन कैसे मेज़र करेंगे? तो डायरेक्शन हम एक ओरिजिनल वेक्टर से मेज़र करते हैं. सो कोई भी एक हो सकता है. इट कैन बी आइदर क्यू और इट कैन बी पी, कि ये वेक्टर आर पी से इतने डिग्री पे है, ऐसे हम डायरेक्शन बताते हैं, इतने एंगल पे है पी से. सो लेट अस कॉल दिस एंगल एज अल्फा. Okay, let angle between R and P be alpha. So now I can always say what is the direction of R. See, P is given, so P का direction दिया हुआ है प्रॉब्लम में. मतलब इस पूरे पूरे डिस्कशन की में जो चीज़ शुरू में हमको अवेलेबल है वो है P का मैग्नीट्यूड और P एंड Q का मैग्नीट्यूड, P एंड Q का डायरेक्शन, ये हमको अवेलेबल है. अब हमको R का मैग्नीट्यूड मिल गया है, R का डायरेक्शन कैसे पता चलेगा? So we will assume that, let us say that R makes an angle alpha with one of the two. I will take with P. Okay, and I will try to find out alpha. Okay, now I can use this in this big triangle. There is a big triangle here. I can use tan alpha to find out the direction. Okay, what is tan alpha here? What is the tan ratio? Tan is opposite upon adjacent. Tan is opposite upon adjacent. What is opposite to alpha in this case? Opposite to alpha is Cm and adjacent to alpha is Om. Okay, so it is going to be Cm upon Om. But what is Om? Again, Om is sum of OA and AM. Correct? And what is AM? AM is Q cos theta. We have already found this. So let us write first one of the. Let us write all of these first. We now write down tan alpha. Tan alpha is opposite upon hypo. What is opposite? OM. What is hypo? No, I'm doing ulta. Tan alpha is, what is tan alpha?
Opposite upon adjacent.
Opposite upon adjacent. So in this diagram, what is opposite? Cm. And what is adjacent? OM. So tan alpha now can be written as, what is Cm? Cm को बाद में हैंडल करते हैं, पहले जो पता है वो लिख लेते हैं. OM is OA plus AM. Correct? Cm is Cm upon OA, we know it's P. AM you know it's Q cos theta. ऊपर हमने derive किया था. Now you have to find out Cm. Now if you look at the drawing carefully, Cm is the front. It's opposite to theta. So opposite है तो I can use a sine function. What is sine theta? Cm upon Ca, that is hypotenuse. I think we have to call it AC. So Cm upon AC. Cm upon AC is Q. So Cm क्या होगा? Q sin theta. So I can write Q sin theta upon P plus Q cos theta. This is tan alpha. So what is alpha? How do we write alpha? So alpha वो एंगल है जिसका कि tan ये सब है, तो उसको हम लिखते हैं tan inverse. I'll explain you later. Q sin theta upon P plus Q cos theta. So this is gives you alpha. So these two equations, one is this gives you the magnitude and this gives you the direction. Well, triangle law in general gives you about ideas about the vector addition.